Hello everyone. In this video, I'm going to explain AWS IAM, that is Identity and Access Management. AWS IAM is a service that help you securely control access to AWS resources, and it also allow you to manage users, groups, roles, and permissions to ensure your cloud environment stays secure. I'll cover key concepts like users, policies, rules, and authentication methods to help you understand how IAM work in AWS. So let's go and see what are the topic I'll be covering in this video. So I'll explain you about what is IAM, why we need, and what are the key components, and IMA users, group, roles, policies, and what are the disadvantages and advantages of IAM. And at the last, I'll show you demo on how to create IAM. So, what is AWS IAM? So, when it's come to AWS IAM, so it's a identity and access management. It is a secure service provided by a Amazon Web Services that help you manage access to AWS resources in a controlled and a secure way. You can access your data in a secure way, and it enables administrator to create and manage user groups, roles, and define permissions for them to access specific AWS services and resources. So don't worry about how to create and all. I'll show you at the last. I'll show you demo on that. So with AIA, IAM, you can implement the principle of least privilege by giving users only the permission they need to perform their jobs, reduce the risk of the security breaches. So in the root access, you are going to create a IMA users by giving some particular permissions. On that basis they need to work on that. So it also supports multi-factor authentication for an extra layer of security, and allow access to AWS resources through the AWS Management Console CLI. And IAM policies are defined using JSON based policies documents that specify actions, resources, and conditions under which access is granted. And it also supports federated access, enabling user from external identity providers like Google or Activity Directory to access AWS resources securely. IAM is free to use, but the AWS services you access may incur charges. Overall, AWS IAM is a fundamental part of AWS security, enabling fine grained access control and ensuring the right people and services have appropriate access to use the resources. So why IAM? Why we need IAM? So it's a crucial for securing and managing access into AWS resources, and it ensures that only authorized users and services can perform on some specific actions. So without IAM, organization would struggle to control who can access their cloud resources, leading to potential security risk, unauthorized access, or accidental changes to critical infrastructure. So, and it also allow administrator to create detailed access policies, ensuring that each user's group or services have the exact permission they need to perform their task, following the principle of the least leverage. So by centralizing access control, IAM simplify managing permission at scale, especially in a large complex environment with multiple teams and services. Additionally, IAM enhance security through features like multi-factor authentication, which provide an extra layer of protection. It also supports auditing and logging to track who accessed what resources and when, which is essential for compliance and troubleshooting. IAM helps organizations flow best practices such as role based access control and a temporary credential, which are vital for maintaining secure cloud operation. So IAM is an essential tool for managing cloud security and ensuring that access to AWS resources in a tightly controlled, traceable, and aligned with the organization policies. The overall for the security and a authorized person to access the resources. So for that purpose, we use the IAM. So let's understand the key concept in IAM. Let's see what are the concepts we have. So the first concepts we have is a user. So it's an individual identity with specific some permissions. So a user represent an individual identity within AWS. So it can be a person or a system that requires access to AWS resources. And what are the characteristics of the users? User are assigned specific permission to perform action within the AWS environment. So each user has a unique username and a credential, passwords, access key, and everything. So when you see the use case of the user, you would create a user for each person or application that needs to interact with the AWS resources. Don't worry about this. I'll show you on when we do the practical session. So the next thing we have is a groups. So it's a collection of user with similar permissions. So a group is a collection of IAM user who share similar access permissions. So when we see its characteristics, so groups make it easier to manage permissions for multiple user at once. Permissions are granted to the group, and all users within the groups inherit those permissions. So, when we see the use case of the group, if you have a team of developers, you can create a group called developer and assign appropriate permissions like they want, I example for they want easy to access of that group rather than assigning permission to each user individual. So the next concept we have is a role. So it's a temporary permission that can be assumed by user or a services. A role is a set of permission that can be assumed by IAM user or a AWS service temporarily. So when we say its characteristics, roles do not have a permanent credential like users. So instead, they are assumed temporarily. Roles are often used to grant permission to applications, AWS services like EC2 instance or a Lambda functions, or user from different AWS accounts. When assuming a role, an entity is granted a set of permission that they can use it for a limited time, and it does not have a permanent credential. It has only a temporary credential. When we see its use case, a role might be used to allow an EC2 instance to access S3 buckets or for an AWS services like Lambda to perform task in another AWS account. So the next we have is a policies. So it's a JSON documents that define permissions. Policies are JSON documents that define what actions are allowed or denied on a specific AWS resources. When we see its characters, policies specify permissions in terms of action, resources, and a condition. So when we see its actions, it's defined what can be done. Resources specify which AWS resources that action can apply to. Conditions define when the permission is granted. Policies can be attached to user groups or a roles of anything. So we have some types of policies, that is identity based policies. In these assigned to user groups or roles to grant a permission, and we have a resource based policies attached to resources to specify who can access those resources, and AWS managed policies, predefined policies created by AWS that can be attached to the users groups or a roles, and we have a customer managed policies created by the user that can be customized for a specific needs. So these are the key components in identity access management. So the next we have a let's understand one by one. that what I have explained in a previous slide, that is key concepts. So now let's go on in depth of the user in AWS. So, an IMA user is an individual entity within a AWS that is associated with a specific set of credential which allow that identity to interact with the AWS, that would interact with them. So, in this we have a key features of IMA. So, what are the key features? We have a identity. That means each IMA user has a unique name and is an entity that can be assigned within a specific set of credential which allows that identity to interact with the AWS resources and can be assigned permission to access AWS resources. And IMA user are typically created for individuals, like example employee or the services that needs to access to AWS. Then we have a credential. Users are given credential that can be used to authenticate and interact with the AWS resources. In the credential, there are two main types of credential. One is programmatic access and another one is a AWS management console access. When it's come to as programmatic access, it allows access to AWS through the APIs, CLIs or other tools. This is done using access key and a secret key. So AWS Management Console access allow user to sign in to the AWS Management Console via password. So the next we have is a permission. Permission can be assigned to IAM user directly or through groups or roles. These permissions determine what action the user can perform on AWS resources. Permissions are granted through policies which define what actions can be performed on which resources. So let's understand the use cases of IAM users. So here I have taken a three, that is employee services and a auditing. So when it's come to its employee, different employee needs access to AWS resources like EC2 instance, S3 buckets, RDS database, etc. Each employee would be assigned their own IAM users. So when it's come to its services, some services or application may need access to AWS resources, like example EC2 instance accessing an S3 bucket. In such cases, IAMA users or a role can be created for that services. The next thing we have is a auditing. So creating separate IMA user allow for better auditing and track of who performed what action in AWS, as each user has a unique credential. And let's understand the example use cases. So here employee access, a company has multiple employee working on different project. For example, the developer need to access EC2 instance and the database administrator need to access the RDS. So that what the developer needs to access EC2 instance and the database administrator want to access RDS. So each employee is assigned a IAM user with the permission relevant to their role. So the developer might have a programmatic access to EC2 instances and CLI tool along with console access to manage and launch the EC2 instance. They can developer with the permission they can launch the EC2 instance. So the database administrator might have access to a RDS console to manage database. So by creating distinct IMA user for each person, it ensures that only the required resources are accessible, reducing the risk of over permission accounts. So the next we have is a group. So, an IMA group is a collection of IMA users that shares the same permissions. Group allow you to manage permission for multiple user at once, making it easier to apply consistent access control across a set of user who perform similar tasks. So let's understand the key features of IMA groups. So in this we have a manage permissions for multiple users. Groups simplify the process of managing permissions by allow you to apply a set of permission to all users within the group rather than assigning them individually to each user. When you add user to a group, they automatically inherit the permissions assigned to that group. So user inheritance. User within a group inherit the permission assigned to the group, but they can also have their own individual permission, which can either extended or restrict the permission inherited from the group. A user can be a member of multiple groups and will inherit the permissions from all groups they are a part of them. So we have a no credential. Groups do not have a credential such as access key or a secret password. They are simplified way to organize user and a manage permission. It does not have any credential like access key and a secret key. So the next we have is a policy assignment. So permission is IMA group are defined by policies. Policies are attached to the group and user inherit these policies. Policies define what action user in the group are allowed or defined to perform on AWS resources. So let's understand the use case example. So here have taken a developer group. Imagine a scenario where you have a team of developers who need to access to some specific AWS resources such as EC2 instance and a S3 bucket. Rather than assigning a permission to each individual developer, you create a developer group and assign the relevant permission to these group. Like example EC2 start instance, EC2, stop instance, list bucket, put object. Once the developers are added to the developer group, they will automatically inherit the permissions specified for that group. These ensure that all developers can perform some actions on EC2 and S3, streamline permission management. So the admin group for first I have taken a developer group, so here I'm taking a admin group. For group of administrator who need full access to AWS resources, you can create admins group and assign a policy that grants administrator access. All user in the admins group will automatically have admin level access to the AWS services. So the next key concepts we have a role. So, an IAM role is a set of permission that can be assumed by trusted entities such as users, applications, or AWS services. Unlike IAM user, roles do not have permanent credential like passwords or access key. Instead, when a role is assumed, temporary security credential or provided the entity assuming the role. So let's understanding the key features of IAM role. So here we have a temporary permissions because roles does not have a permanent credential. So they use as a temporary permissions. So role provide temporary security credential that allow trusted entities to perform action on AWS resources for a limited time. Once a role is assumed, the trusted entity can perform actions defined in the role policies, but the credentials are valid only for a specific period. So the next we have is assumed by trusted entities. It's only trusted entities, that is user, and I am a user can be assume a role to gain additional permissions for a specific task. AWS services such as EC2 or a Lambda can assume role to interact with other AWS resources. For example, an EC2 instance can assume a role to access an EC3 bucket. Cross account access, IAM role can be assumed by users or services in different AWS account, enabling secure access between AWS account. No permanent credential. I already told it does not have a permanent credential, it only have a temporary credential. Does not have a long term credential like passwords or access key. Instead, the role provide temporary credential which helps to reduce security risk. And we have a policies. So just like IMI user are associated with the policies that define what actions are allowed or denied, the permissions granted by the role are determined by the policies attached to the role. The next we have is the role trust policies. A trust policy is defined with the entities like users, AWS services, and other accounts are allowed to assume the role. This is the different from the permission policies, which define what action can be performed. So let's understand the use case of example. So here I have taken EC2 instance accessing the S3 bucket. On common use case for IAM and role is allow EC2 instance to access S3 buckets rather than storing AWS access key or the instance, which is a security risk. You can assign IAM a role to the EC2 instance with the necessary permission. So here I'm creating a IAM a role with policy granted to the S3 bucket. For example, the policy might allow the EC2 instance to least upload files to an S3 bucket and assigning the role to the EC2 instances. When launching the EC2 instance, you can assign the IMA role to the instance. The EC2 instance will now assume the role and use the temporary security credential to access the S3 buckets. So the next key concepts we have is a policies. So it's a JSON document used to define permission in AWS. They specific what actions are allowed or denied on some specific AWS resources. Policies are attached to the IAM users, groups, and roles to grant them the appropriate access rights. So let's understand the key features of IAM policy. It has a actions define what operations are allowed or denied, and we have resources. It defines which access resource the action can be applied to, and we have conditions define optional conditions under which the permissions are granted, and for example it's based on IP addresses, time, and multi-factor authentications and etc. So let's understand the advantages and disadvantages of identity access management. So identity access management is a critical services in AWS that allow you to manage users, group roles and permissions for secure access to our AWS services. And also we have some advantages and disadvantages in AWS. So the first advantages is it is completely a secure authentication. It support multi-factor authentication for added security, ensuring the access to AWS resources is protected by more than just a password. And we have a centralized access management. You can manage user permission across multiple AWS services for a central location, streamlining security management. And we have a integrated with other AWS services. It integrated with all AWS services, enabling management of permissions and access control across your entire AWS infrastructure. And it has a temporary credential. Role can be performed temporary credential for user or services that need limited time access, helping reduce the risk of long-lived credential. And we have a scalable. It is designed to scale with your organization, whether you have a small team or a large enterprises with complex permissions and a requirement. So let's understand the disadvantages. So first thing we have a complexity. For large organizations with many users, groups, and roles, IAM policies and a permission structure can become complex and hard to manage effectively. So, learning curve. So, understanding IAM best practices, policies, and difference between roles, users, and groups can take for new users. So, misconfiguration risk. Misconfiguring IAM policies can lead to security vulnerabilities such as granting overall permissive access to sensitive resources, limited governability of the some services. Mm, while IAM is highly kernel for many AWS services, there are still some services where finer access control may be limited potential leading to security risk. And overall for managing permissions, constantly managing and auditing permission for users and roles in a large AWS environment and can add administrative overhead. Policy complexity. The JSON syntax for IMA policy can be difficult to understand, and writing complex policies without error can be challenges. In summary, AWS IMA offers powerful access control features but requires careful management to ensure security and minimize complexity. So these are the concept of the IAM. So let's go to the AWS account. I'll show you how to create users, groups, roles, and permissions, policies. Everything I'll be showing in a practical. So let's go to the AWS account. So let's start with the practical session. So go to the IAM console. So click on IAM. So see, in the left side corner we have a dashboard. In the access management we have a user groups, users, roles and permissions. What are the key concept I have explained in the theoretical part. So this is how what we are going to creating now. So let's click on user and let's create one user. So these are the user I have. So I'll show you. Click on create user. So give the username. So here I'm giving the username called user demo. So provide user access the AWS management console. Click on this, check this. So here we have two types of permissions. Are you providing console access to a person, or user type specific a user identity center? No, here I'm creating a, I want to create a IAM user. So here console password. So here we have a auto generated password or we have a custom password. If we generated auto generated password, the AWS give us some password. After login to a particular user, then we can change the we can customize our password, or else you can directly click on customize password. So you are here provide a password. So user must create a new password for the next sign in recommended. No, uncheck this. So click on next. So see here we have a permission options like add user to groups, copy permissions or attach policies directly. So here I'm not creating anything. Only I'm just creating a user and I'll show you what the user can do. So click on a next. So click on create user. So see, the username is user demo and I have given a password. So if you want the content like so here in a CSV file they mention the login URL and your username and a console password. What are the password you have given, that is mentioned in the cs.cs file. If you want you can download this file. The thing I'm now doing is, so let's log into the IMA console. So see in the download .csv file, I can see the URL of the IAMA user. In through that URL, I have came across here. So you are asking the IAM username. So what the username I am giving? The username, yeah, I have entered here, and you need to give the password that you have given while creating the user. So click on sign in. So the user is logging through the IAM user, that with the access username with the password, the user has been logged in. So see here, so if you want to access S3 bucket, so let's go to the S3 and try to create S3 bucket. So click on create bucket, give the name. So just click on bucket. See, already exist. So fail to create bucket. To create a bucket, S3 create bucket permission is required. So while creating the user, I have not attached any policies, any role to a specific or a individual user. So this is how the things will work. So let's go to the created user. So it's showing sign in again. So we have created this one and then run this one. So now this is also created to the user demo. So we need to provide a permission for this. So go to the user demo. So here we don't have any permission policies, right? So click on add permissions. So add permissions. So here add user to the group I don't want, copy permissions I don't want. Here I'm attaching the policies directly to the user. So what the thing we need to do is, so give the permission only for the S3 bucket. So if you type S3 in the search bar, so it will show all the selected ports you want. So click on Amazon S3 full access. So and click on next. So and add permissions, add permission. So this will give us the S3 full access. So let's go to the IAM console and let's see we can access the S3 bucket or not. So let's check whether the S3 bucket we have access or not. Which so so as we have, so click on create bucket. So here I'm creating the bucket. So click on create bucket. So as the bucket has been created with the permission, that's with the policies and all, the user will created the S3 bucket. So this is how the user policies will work. So, and the user can also create the access key by clicking here create on access key, or else if go to the secret credential, scroll down. So here the URL of the user. So here we have a create access key and a secret key. Here we need to use a command line interface. So this will access to enable access to your account. So click on next. So check this. So click on next. So it will create a access key and a secret key for to securely store your data. For that purpose you can use access key and a secret key. This is how the things will work. Click on done. You have not viewed or downloaded. So if you want, you can click download the files. So done. So this is the way the access key and a secret key. So see, for the user the access key is now activated. So, I have shown you policy, right? So, policies we have these types of policies we have for a particular user. We can provide those policies, and we can also create a users. So, click on create users. So, trusted entity type here I'm using AWS services. So, in the use case, I'm using the EC2 instance. So, click on next. So here, what the policies or the permissions you want, you can access. Here I'm giving the full access to the EC2 instance. Click on this. So click on next. So you need to provide the role name. So here I'm giving EC2 demo. So what the description it's telling, allow EC2 instance to call AWS services on your behalf. So the version and the action, the principle, it will, this is the, it is in a JSON format. If you want, you can edit this. So click on create role. So this will create a role for you. So where I have created EC2 demo, right? So yes. So if you created roles like this, and when you when you're creating some services, at that time you can use existing roles and things you can use, and you can come here and add the attaches policies directly and all. This is the things the role will work. So I'll show you the key concept of users, roles and policies. I have not still shown you the group, right? So click on user group. So here we don't have any group. So click on create group. So give the username called, I am giving here developer. So here in the name of the group, so here I'm using the user group. And so what the policies the user and the team want. So here I'm giving the EC2 full access. So click on create user group. So what the group will do is, so if we have a 10 or 20 that kind of users in a developer team, the user wants, what the user wants to do, they want to go and give the permissions for the particular user. Instead of doing that like that, so what the user does, just create one group called developer or something you want. So go to the developer and add the users that what the developers group wants. Add all the users to that and give the policies for that developer, and it will give permissions for all the users. You don't want go and create it for a particular user. So this is how the developer group will work. So this is all about the practical session of the IMA user, that is identity access management. So that's all about the identity access management. Thank you.